Hi, it's Mr. Reisky, and this is Collaboration Day for teachers, which means more or less a half day of school for students. Today in class, we did 3 short labs called Discount, Odd Even, and Num5s. The lab instructions are in your email from this morning, and I'll just quickly go through them. You can pause as necessary, of course. The first one, Discount, you want to ask for an amount. Store that in a double. And then you want to see if it's 50 or more. If it's 50 or more, we discount it by 10%. So 50 minus 10% becomes 45. If it's 80, 80 minus 10% becomes 72. So if amount is at least 50, then amount, all kinds of ways to do the math, but just times equal 0.9 does it, right? So if amount was 50 exactly, times equal 0.9 makes it 45. If it was 100, it makes it 90, and so on. And then display your amount. Don't need braces around my body of my if because it only has one statement. Let's see if this works. So put in 70, should come up and subtract $7. That's 10% off and be 63, and it is. Okay. Make sure it does not discount for something below 50, like 30. And it stays 30. Don't worry about the decimals. We haven't learned how to actually format 2 decimals. That's not a big topic for the AP exam anyway. Okay, the next one was odd or even. Very classic programming lab. It's in just about every textbook you can find that introduces programming. So we'll ask for a number. Okay, and we'll just store an int num. And then again, I asked the class to think about how they explain to their 3rd or 4th or 5th grade teacher that a number was odd or even. A number is even if it's divisible evenly by 2. That means if you divide it by 2, it has no remainder. That means modulus 2 is 0. So if modulus 2 is 0, then we know it's even. If it's not even, it's got to be odd. There's only 2 choices, right? So don't add a second if. You don't need to. And let's see how we type that in. Okay, good. Run it. Enter a number. So we'll say 12, and we see even. Good. Again, we'll put in 9, and we see odd. Looks like it's working. Okay, and the final one was more of that modulus 10 stuff, more of that division by 10 stuff. We're counting the number of 5s in a 3-digit number. So we ask for a 3-digit number. Store it. And now you can do this a lot of different ways. I try to keep things organized for students who are first-time programmers, who are new at this. So I'll separate the ones digit by doing num modulus 10. Okay. Separate the tens digit. I'll separate the hundreds digit. Okay, well the ones and tens digit, the ones and hundreds digit are just one arithmetic operator. They're much easier than the tens. The tens has 2 steps to it. You could do it that way, and you could do it different ways. You could use subtraction somehow, but hopefully I'm keeping this pretty short for you. And if the number is 123, then 123 modules 100 is 23, and 23 divided by 10 is the 2. 2 with the original tens digit in 123. And so now we count to see if we have any 5s up there. So if then maybe have a count variable that's initialized to 0. Okay, this is quite a bit different. No doubt this caused kids to go very slow in class on this today. This was a little bit different and twice as much code, of course, as the first couple. Okay, so let's see if I typed it in okay, compile it, good. Number of 5s. So let's put in 555 and see if we get 3. Yes, okay. Let's run it again with maybe 2 5s this time. So 4, 5, 5, 2 5s, 3, 4, 5, 1 5. You should do more checks just to make sure all 3 of the positions work. Like not just do 3, 4, 5, but do 5, 4, 3. Still 1. And 3, 5, 4. Didn't check the middle one yet. But if 5, 5, 5 works, it's probably working. And then make sure you get 0, of course, if there's no 5s. Okay, thanks for watching. Take your time, practice. Tonight's homework is all you have to do tonight are those 6 new coding bats in Logic 1, the first 2 rows of Logic 1. Again, thanks for watching.